Most people write prompts like they are texting a friend. They type, "Write me a marketing email," into a chat box and hit send. But an API does not see a conversation. To build reliable software, you have to structure your request as a structured JSON API payload, explicitly separating the system instructions, the user prompt, and the assistant's response. A large language model has no concept of human intent. It processes every token you send as a literal, mathematical instruction. Vague requests yield a wide, chaotic probability curve of possible next words. A strictly structured payload forces a narrow, highly precise probability spike. When you get generic, bloated, or unusable text back, it is not a failure of the underlying model. It is an instruction problem. The model is simply wandering through an under-constrained output space. Prompt engineering is the physical interface bridging human intent and machine probability distributions. Controlling that interface requires understanding three things: the anatomy of an API call, the logic of textual constraints, and the math governing sampling parameters. Systematically managing these distributions allows for a predictable workflow where human intent is mapped directly to machine capability. Every API call has three distinct structural blocks: system, user, and assistant. The system message acts as the highest priority context. Illuminating and locking into place, it establishes the model's identity, behavioral rules, and strict constraints for the session. The user message defines task boundaries, but without a strong system block, it lacks required constraints. To guarantee output formatting, the assistant prefill activates, supplying the first tokens, like an opening curly brace for JSON, physically blocks conversational preamble. Anthropic's API supports this prefill technique natively. OpenAI does not, requiring you to use their specific structured output mode instead to achieve the same guarantee. Structurally segregating these inputs creates a firewall. It protects the application from prompt injection attacks while simultaneously guaranteeing deterministic output formatting. The instruction, "You are an expert," functions as a mathematical filter for the model's training data. This point cloud represents an LLM's training data. Role assignment acts as an activation function to bias sampling. A generic role samples broadly, but a senior backend engineer isolates a narrow, high-quality slice. Hyperspecific roles force the model into an empty void. Operating in a space without high-quality text mathematically guarantees hallucination. The model will produce confident nonsense because it lacks the data density to form a correct answer. Optimal role prompting requires finding the exact balance point, maximizing domain specificity while ensuring a high density of quality training data remains available. Every textual ambiguity in an instruction is a literal branch point where the model's attention mechanism is forced to guess what you want. This bounding box shows an unconstrained prompt's output space. Negative constraints, like "do not include code," slam down, eliminating massive regions of invalid generation. Positive constraints, like "always cite sources," erect rigid structural pillars, guaranteeing specific elements in every response. To apply these constraints cleanly, you must use XML tags and explicit delimiters. This programmatically separates your rules from the main data payload. Providing explicit formatting instructions overrides the unpredictable default markdown behaviors inherent to different models, ensuring a uniform structure. Reducing the pathways of valid output directly increases the probability of retrieving the exact intended result. Text-based constraints narrow the options, but you also have to control the underlying randomness of token selection at the API level. This curve represents a standard logic distribution. Temperature is a scaling factor applied to this distribution. Pushing it above 1.0 flattens the curve, increasing randomness. Dropping it to near zero sharpens it into a single deterministic spike for exact data extraction. Alternatively, you can use top P, also known as nucleus sampling. It strictly cuts off the long tail of the probability curve. Tokens outside the specified percentage are completely deleted from consideration. There is a critical engineering rule for these parameters: tune temperature or tune top P, never both simultaneously. Altering both probability controls at the same time causes unpredictable mathematical collisions, breaking your carefully designed constraints. Building reliable production applications requires locking down these parameters to match your specific task requirements before running a single generation. A production pipeline requires architecture that survives provider differences. Your prompts must execute reliably across OpenAI, Anthropic, and Google models without breaking. Achieving this means writing instructions in plain English and using standardized XML delimiters rather than relying on platform-specific markdown tricks. This chart compares a massive 100,000 token input filled with 90% noise against a compact 10,000 token input of pure signal. A massive context window is not a license to dump unfiltered data. Injecting too much context introduces noise that actively degrades the model's attention mechanism, making it harder for the system to locate your critical instructions. True context engineering aggressively curates exactly what is allowed inside the window, rather than filling it to the limit. The final requirement for an enterprise LLM application is a programmatic multi-provider testing harness. During this testing phase, temperature must be set to exactly 0. This strips away sampling randomness, isolating the structural quality of your prompt to ensure the output is entirely deterministic. These deterministic outputs are then systematically scored against your expected format compliance and strict constraint adherence. The resulting data dictates the iterative refinement of the prompt. You adjust negative constraints and XML delimiters based on where the model failed the test. Prompt engineering is the baseline interface of AI development. Only by mastering the probability distribution can engineers build truly reliable systems.